This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is part 7 of Vector Basics, and in part 1 we defined scalars and vectors, but we've been mainly working with vectors, so we've been looking at vectors on the page which look like directed line segments. In other words, they look like they have some arrows, something like this. Down here in green, it has a magnitude, which is the length of the vector. It's got a direction, that's why the arrow is pointing a certain way. And we've also been able to write it in this component form, and we've added vectors, and we have figured out the length or magnitude of a vector. So now we're going to work a little bit more with scalars and vectors. So here's the first thing to consider. Let's say we've got 3 vectors, vector u, vector v, and vector w. And I want to draw this vector. Notice there's a minus sign. You can think of this as the negative of vector u, negative of vector v, and the negative of vector w. You might call that minus u, etc. So how do you think you would do that? So think about that. Actually, all you do is you have the same length. Negative u has the same length. It's just going the opposite direction. So if I look up at u here, then if I want to do negative u, you just switch the direction, and that would be a picture of what, so it's, sort of like the same parallel line, basically, and that's what negative u looks like. If you want to do negative v, it's got this the same length, but it's going the opposite direction. So negative v is something like this. That would be negative v. And similarly, if we have negative of the vector w, it would have the same length as w, but it would go in the opposite direction. So it looks like this. Now you could think of this negative in front of the vector as the number -1. So you could think of this as negative, this could be thought of as -1 u, all right, that's the vector u. And the number in front of the vector is a scalar. So remember we talked about a scalar is basically just a number, but it might represent something, the meaning of it might be something more than a number. It might have to do with something else like miles per hour, etc. So this is the scalar, okay? So the number in front of the vector is just called the scalar. So we have just drawn negative u, negative v, and negative w. All right, so what do you think it would mean if I said draw 3u? Well, actually it means you start with u, and 3u is going in the same direction as u, but it's 3 times as long, so it's like you're stretching u. So if you have u right here, which looks like it's going about here, all right, so let's say it's about that long, u. You got to keep going, and you got to keep going until you get 3 of them, and then that's where it ends up. So this is just a sketch of 3u. All right, negative 2v. Well, the negative sign tells you it's going to change direction, and the 2 tells you it's going to be twice as long. So we take the length of v right here, which looks like it's about that long and going about, in that parallel direction to v that you see up here. And I've got to do it twice as long, so let's say it's about this long. I'm just freehand drawing it, of course. If you had a ruler, you can get it more exact. And now if I did 2v, the arrow would be up here at the right, but I've got negative 2v, so it's down here. And the last one, 2w, well, if this is w, then 2w would be twice as long. So again, freehand drawing this, so I've got w because maybe it doesn't look quite right. Okay, W looks like it's going about like that. Still doesn't look right to me. That's about the right length approximately. And then you're just going to stretch it out. Okay, and it's going to keep the same direction. So this is 2W, and this one was negative 2V. So the scalars are the coefficients right here, right? So these numbers are the scalars. For the problems that I just did. Let's make it black. And there we go. So let's say you wanted to draw V minus W. You could think of that as V plus negative. And I forgot to put the little line here. V plus negative W. Right, so we did vector addition in the last video. So we start with vector V. Right, so here's vector V. And now we add on to that negative W. So what would negative W mean? It would be the opposite direction. So it's going to go up. So we take at the end of this first vector, right? And then we're going to draw what negative W looks like. So remember, negative W looks like this. So we're going to have to draw this. That's what negative W. So that's what V minus W looks like well, we're not done. Now we have to write our answer, the directed line segment or the finalized vector right here. From where you started to where you end, and that is what we're looking for. That's V minus W. All right, let's do one more drawing. Draw 3U plus V. All right, so I begin with 3U. So I'm going to have 3 times as long as that. So let's say it looks something like, that looks like about 1, 2, 3 of them. Okay, so that is my 3U. Okay, and then at the end point here, right, of 3U, I'm going to add on V, so I have to add V onto that. Well, that looks like it's something like this. Whoops, not really. A little bit more. Something like that. So what our answer is, from the beginning of the first one to the end, etc. And so that's where it is. So this video just focused on, if you're given vectors, how would you do your, this is called scalar multiplication. I'm using scalar multiplication, and then I'm adding or subtracting vectors. Because instead of just having 2 vectors like V plus U, I might have something like 3U plus V. So scalars are now involved. In the next video, we'll talk about scalar multiplication more algebraically. This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.